Hi, this is Leetcode question, maximum subsequence score. This is the third question of biweekly contest number 96. So you are given two zero-indexed integer arrays, nums1 and nums2 of equal length n and a positive integer k. You must choose a subsequence of indices from nums1 of length k. For choosing indices i0, i1 up to ik minus 1, your score is defined as the sum of the selected elements from nums1 multiplied with minimum of selected elements from nums2. It can be defined simply as nums1 of i0 plus nums1 of i1 up to k minus 1 multiplied by the minimum in nums2 for these indexes. Return the maximum possible score. Now, for example, here we have these two arrays, nums1 and nums2, and we have k equal 3. So the possibilities, for example, here we need to pick 3 values because k equal 3. So we can select this, this, this in nums1. So we selected 1, 3 and 3, and the corresponding values in nums2 is 2, 1, 3, and the minimum of these is 3. So the score will be 1 plus 3 plus 3 multiplied by the minimum, which is 1, and this equal 7. Now, other option to select subsequence, we can take this one, and this is 3, and this 2, and the corresponding elements in nums2 are these one. So for nums1 we have 1, 3, 2, and for nums2 we have 2, 1, 4, and again the minimum is 1. So the score will be 1 plus 3 plus 2 multiplied by the minimum in nums2, and this equal 6. Now if we choose to take this 3 and this and this, and in nums2 the corresponding elements are these, and the minimum is again is 1. So for nums1 we have 3, 3, 2, and the summation for this is 6 plus 2, 8 multiplied by the minimum in nums2. So we have 3 plus 3 plus 2 multiplied by 1, and this equals 8. Another possibility is we can take this one, then this 3, then this 2, and in nums2 we have to take the same indexes. So we have this one, and we have this, and we have this, and the minimum in nums2 between 2 and 3 and 4 is 2. And for nums1 we have numbers 1, 3, 2, the one we selected here. The summation for this number is 6 multiplied by the minimum from nums2, and this equal 12, and this is the maximum value we can get for this example, and so we should return 12. Now how can we solve this problem? First of all, the idea is we need to sort the values in nums2. So this nums2 become 1, and then 2, then 3, then 4, and in nums1 we will have the proper value in each index. So 1 for nums2 represent 3 in nums1, so 1 is here, so 3, so this is let's call it v2, and this is v1. Then we have in nums2 the value 2, this is at index 0, and the value in nums1 is 1. Then we have 3 is here, and this corresponds to this index. The value in nums1 is 3. Then we have 4 is 2 in nums1. So we sorted nums2, and for every element we put the proper value from nums1. Now what we need to do is for every index, so we have k equal 3. Now for the value 2, why 2? Because this is n4 minus 3 equal 1, which is this index. So we have this window equal 3. So if our minimum is 2 in nums2, what is the summation, or what are the best 3 values in nums1? And the best 3 value will be in this range, and that's because we ignored this value 1. We are taking from 2 and going to the right, and it's guaranteed that this is the minimum, and so the best 3 values will be among these. So we have 2, and we have these 3 value. 1 plus 3 is 4, plus 2 is 6 equal 12. So this is the first value. Then as we iterate, we move to the second value. So we start from n, the number of element, minus 3. This is our first index. Then we keep iterating until the first index in the array. So we started with this index, then we moved to this one. Now we have 1. 1 is the smallest element. What is the 3 values in this array that are the maximum? So we have 3, and we have 3, and we have 2. These are the maximum 3 values, and so 3 plus 3 is 6, plus 2 is 8, multiplied by the minimum 1 equal 8, and we take the best answer of these. And so the idea is for every element in nums2 we consider it as our minimum, and we need to find the best number of k values from that index, moving until the end of the array. And to do that in efficient way, first of all, let's do the sorting. To do the sorting, we need to store a vector of pairs for nums2, and these pairs contains the value with the index. So nums2, so v2 contains 2, 0. 2 is the value and 0 is the index, so this is the first pair. The second pair is 1, and 1 is at index 1, so this is 0, 1, 2, 3. These are the indexes. So 1 is at 1, then we have 2 at, or 3 at 2, then we have 4 at index 3. So this is v2. Then we need to sort this array. After sorting it, it become 1 is the smallest one. So 1 is at 1. Then we have 2, which is at index 0. Then we have 3, which is at index 2. Then we have 4, which is at index 3. Now this is the value of v2. Now for v1, we need to sort nums1, but based on this sorting. So we need to fill v1, and to do that we will iterate over the values in v2. So the first one is at index 1, so we need to get at index 1 from nums1, so the first value will be 3. Then we have this index 0, which is the value 1, so the next value is 1. Then we have index 2, which is this one is index 2, so we have 3. Then we have index 3. Index 3 is this value, so we have 2. After that, what we need to do is, as we said, so when we have nums2 sorted, or v2, we will iterate from right to left, and we start from this window, which is equal to k. We start at this index, and for every minimum we will check at nums1 the best or the maximum k elements. And to do that, we need to use priority queue, and this is min priority queue. Here we have the value sum and the value answer. This is the final answer where we will store our value. Then we need to iterate over the first, or we need to calculate the first window. So this is the array nums2 or v2. So this is the first index. As we said, we need to iterate from right to left, and we start at this index, and so from here to here we will calculate what is the score for this window. And so for integer I equal n-1 up to n-k, we iterate and we push it to the queue, and we add the value to our sum v1 of I, and this is the first option we have for the score, which is sum multiplied by this index. Now we need to iterate over nums2 for every index and see if we get better answer. And this is what we are doing here. From n minus k minus 1, so we started here, then we start from this iteration from this index up to 0, and for every index we consider it as the min value in nums2, and we need to check if the value in nums1. So now pq, after this loop, the priority queue contains k elements, which are the last k elements in v1. Now while iterating this way, we need to check if the first element, which is the least value, which has the least value in the queue, if it's less than the current value in nums1 or v1, what we need to do is to replace it with this value. So we take the minimum element in the queue and we replace it with this one, which is v1 of I, and by this we guarantee the queue always have the best or the maximum k elements. Now because we replace it, then we subtract the value of the minimum element in the queue, then we remove it from the queue, then we add or replace it with our element in nums1 or v1, and we add this value to our sum. So for example here we have the first three elements. The queue from this loop will be these 2, 3, 1. So the queue will be 1. The queue will be 1, 2, 3. Then when we come to this to calculate for this value, 3 is greater than 1, so we take this from the queue. And before that, the sum is 3 plus 2, 5 plus 1, which is 6, and the minimum is this value 2. So we have 2 multiplied by 6. Now to check for 3, as we said, so 6 multiplied by 2 is this value we calculated here. Now for 3 is greater than 1, we take 1 from the queue, and the sum become 5. Then we add 3 to the queue, so the sum become 8. And this is the best 3 values from this index up to the end of the array, and the minimum is 1, so 1 plus 8 is 8. And here we take the max of the answer and the current iteration answer.